Hi, welcome to another video from chapter 3 where we'll go over some basic examples of using compound interest. I'd encourage you to pause the video when I step off screen and copy down this material and start up again when you've got it all on your notebook. Okay, so in a previous video we got our basic formula for accumulated value using compound interest, and that formula is stated up here. If I begin with an initial deposit of principal amount of money, which we'll often call PV sub 0 or AV sub 0, to move that money t years into the future or t periods of time into the future, I'm going to take PV 0 times 1 plus I to the t, where I is our effective compound interest rate per unit of time, and t is the number of periods of time. And again, that word effective indicates that that is a value I will use directly in our computations as opposed to a future idea, which will be called nominal. Because compound interest is like the default form of interest we use in this course, you can assume that if a problem says interest rate, it means a compound interest rate. If the problem intends you to use simple interest or any other form of interest, it will be very explicit and it will state simple interest. But interest and compound interest will be used interchangeably. All right, so our first example here. Jude will receive $3,000 in 8 years' time. We have an annual effective interest rate of 5%. So that's an annual yearly effective interest rate of 5%. Find the present value of this payment, okay? Now note, compound is never mentioned anywhere, but neither is simple. So my default is this is a compound interest problem. I have a time value of money diagram, which I would always encourage you to do for every problem. And at time 8, we have $3,000, and I'm attempting to drag that money back to time 0 to figure out what its present value is, right? We don't have a present value formula, but we don't need one, right? Here's our accumulated value formula. So the accumulated value after 8 periods of time is the present value times 1 plus I to the 8th, all right? Now, I can take that 1 plus I to the 8th and divide it back over to the left-hand side. So the accumulated value times 1 over 1 plus I to the 8th is equal to the present value. And flipping it around, I could then write the present value is equal to the accumulated value at time 8 times the quantity 1 over 1 plus I to the 8th. All right, so all I did there was I took that power of 8 and also applied it to the 1. All right, and you'll see why in a minute. Okay, so there's my present value formula. Would I memorize this? No, it's just coming straight from the accumulated value formula, and you're just solving for PV0. Okay, all right. Well, so from here I can say PV0, the present value, is the accumulated value at time 8 times V to the 8th, where V is that fraction 1 over 1 plus I. All right. We're going to use V a lot, so that's why I've introduced it in this example. Okay, well, let's actually solve the problem. I've got this great formula, or this great formula if you prefer. So PV0 is the accumulated value at time 8, which was 3,000, times 1 over 1 plus I, our I was 0.05 to the 8th. And if you crank that on your calculator, you get $2,030.52. So another way of thinking about this problem is if you would have deposited 2030.52 at time 0, at time 8, it would have been worth $3,000 if you had 5% interest per period. Okay. All right. So brief recap over here. If I'm going to move a pile of money forward in one period, this is all under compound interest. If I'm going to move a pile of money forward one period, I simply multiply that amount of money by 1 plus I. If I want to move that pile of money forward t periods, I multiply that money by 1 plus I to the t. That is what our accumulated value formula is telling us. Okay. And in the last example, we learned about how to move money backwards in time. So to move a pile of money back one period, I'm going to multiply that pile of money by V, which is 1 over 1 plus I. In other words, divide it by 1 plus I. And if I want to move the pile of money back t periods, I'm going to multiply that pile of money by V to the t, or in other words, 1 over 1 plus I to the t. Or if you like, divide by 1 plus I to the t, right? Okay, so there's V, memorize it. It moves money back one period when you multiply by V. So here's an example of how we can use this. Judy deposits $4,000 into an account today at time 0, and will deposit an unknown amount X into the account in 7 months. Now, the value of these two deposits, this set of cash flows, 4,000 at time 0, X at time 7, at time 4 is $12,810.63. Okay, so how do we know this? I don't know. It's a made-up problem. Okay. We also are told the monthly interest rate is 2%, and we would like to determine X. Okay. All right. Well, let's look at a solution. Always nice to have a time value diagram of money. So at time 0, we plunk in 4,000. At time 7, we plunk in X. And if I move the 4,000 forward 4 periods of time, and if I move the X back 3 periods of time, they total out to $12,810.63. Okay, well, again, assuming compound interest. So the value at 4 months is obtained by taking that $4,000 pile of money and pushing it forward 4 periods, and taking that pile of money, X dollars, and dragging it back 3 periods, months in this case, okay? All right, well, I know the value of time 4 is 12,810.63. I know my I is 0.02, so I can throw in the value of the pile of money time 4 months, the value of I, there's the value of I again, and I get a very nice basic algebraic equation where the only thing I don't know is X. So solving for X with some algebra yields that it must have been a $9,000 deposit will occur at time 7 in order for the value at time 4 of both piles of money pushed to time 4 totaling up to $12,810.